Hi dear students, once again welcome back to our channel. In this video we are going to revise a pair of linear equations in two variables, that is chapter 3. I am giving a very quick revision upon this lesson, so please do watch this full video so that you are getting the concept from this lesson and hence you can easily solve all the problems from this lesson for the board examination. Okay, see, in the last year you have learned what is a linear equation in two variables. Okay, we know what is a linear equation one variable, that is ax plus b equal to 0. If it is two variable, that is the general form is ax plus by plus c equal to 0. Ax plus b equal to 0 is a linear equation in one variable. Okay, here see, you can see only one variable and b is a constant, a is any real number and that is a coefficient of x also. But in linear equation in two variables, okay, see ax plus by plus c equal to 0. This is a general form of a linear equation in two variables. Okay, sometimes you are getting the constant in the RHS, so you can take that into LHS and you can make that equal to 0. That RHS part you can make it as 0. Okay, and you know that the graph of this linear equation two variable is always a straight line. And it has infinitely many solutions. Okay, what is solution, children? The value of x and y which satisfies this equation. For example, see 3x plus 2y minus 3 equal to 0. This is a linear equation in two variables, that is x and y. Okay, and for this equation, you can see that for infinitely many values of x and y, this you can make this LHS equal to RHS. Then only those values are said to be solutions of this equation. Okay, and when you plot the graph for this, you can see that it will be always a straight line. The graph of a linear equation in two variable is always a straight line. Okay, but what is our topic? Pair of linear equations in two variables. Okay, see, pair means we should have two equations, two linear equations, two variables. Okay, that means I am writing here that is 2x minus 4y, or for time being I am writing plus, both are I am taking positive values. Okay, and plus 5 equal to 0. Okay, so you can see that here also two variables x and y. Okay, so this is a pair of linear equations in two variables. That means we need two equations, that is linear equation in two variables. That pair is what we call the pair of linear equations in two variables, or it is a simultaneous equation. Understood? So how can we express that in its general form? This is a general form of linear equation in one variable. So if we have pair, if you are talking about pair, so can we write again ax plus by plus c equal to 0? Then it both will be equal. So in order to make a change, we should express when we are writing the standard form a1x plus b1y plus c1 equal to 0. Okay, if you are talking about the pair of linear equations, okay, we have to write, this is the standard form, a2x plus b2y plus c2 equal to 0. That means here a1 and a2 cannot be always different, but they need not be always same. That is the meaning of a1 by a2. By writing a1 by a2, the coefficient of x need not be always equal. If you are writing again a1, this will lead to a misconception, that is always the coefficient of x must be same. Okay, that need not be, but it can be equal, that doesn't matter. Okay, see here b1 and b2 are the coefficients of y and in first equation, b2 is the coefficient of y in the second equation, and c1 and c2 are the constant term of both equations. This is a general form of a pair of linear equation in two variables. Okay, then what will be the graphical representation? We know the graph of a linear equation two variable is always a straight line, and this is also another linear equation in two variable. That means this both will be a straight line. The graph will not be a parabola just like quadratic equation. Both the lines will be a straight, the graph of both the equation will be a straight line. Okay, but if we are taking as a together pair of linear equations, okay, the graphical representation we are talking about the next point. Okay, how will be its graph look like? Okay, and for that, whatever the pair of linear equations in two variable you have, when you are plotting the graph by finding the solutions, okay, of one equation you take and get its solution set and you plot the graph for that, and you can see that that will be a straight line. And secondly, you take the second equation, okay, for example this equation, and you write this equation with respect to one of the variable and you get the solutions at minimum 3 values of x and y. What I am saying is you should get the solutions of x and y in this column, okay, and you can plot the graph of the second equation also. And after plotting the graph for two equations, you will see that, okay, see, this is the one possibility. Okay, there are of two types. There are of three types of the graph of pair of linear equation two variable. Okay, sometimes after plotting the graph, this may be the first graph of the first line, first equation, and sometimes that another graph, that is the graphical representation of the second equation, sometimes may be intersecting the first line at this point. That means that lines may intersect. That is the first condition, intersecting lines. And the second case is this: after plotting the graph, you can see that their graph will be of this type. Okay, this is the graph of the first equation and this is the graph of the second equation. In this case, can we say that are they intersecting each other? No, they are parallel lines. Parallel lines. Okay, they will not intersect. How far we extend, they will not intersect. They will always keep a constant distance between these lines. Hence, it is called parallel lines. And in the third case, children, see, after plotting this graph, you can see that one graph, this is the graph of first equation, and after plotting you can see that second graph is coinciding the first line. That is, second graph will lie on the first line, graph of the first line, first equation. And this case we can say that coincident lines. Okay. So these are the three possibilities. These are the only three possibilities. You can see whatever the pair of linear equations in two variables you are having. Okay, after plotting the graph, these are the three cases. Okay, this is what we call the graphical representation of pair of linear equations in two variables. That is, plot the graph of the given pair. Okay, and definitely you can see that any one of these. Okay, in this case, okay, you can see that before plotting the graph, after getting this equation, you can conclude that what will be their graph. Okay, any one of this I already told. Okay, after getting this value, this equation, you can already say that what kind of its graph. Okay, and for that we are comparing the coefficients of x of both the equation, y of both the equation, and the constant term. We are taking the ratios of x, the coefficient of x, coefficient of y, and the constant term. Okay, so after getting these equations, that is the pair of linear equation, okay, before plotting you can say that by comparing the coefficient, here the coefficients are a1 is the coefficient of x in the first equation by a2. Okay, you compare the coefficients or take the ratio b1 by b2 and c1 by c2. Okay, then after getting this ratio, if a1 by a2 is not equal to b1 by b2, you need not find what will be the ratio between this b1 by b2 is equal to or not equal to. You can conclude that its graph will intersect each other. That means for that case, we will say that it has only unique solution. For one and only one values of x and y, this equation will satisfy. Okay, that is the meaning. Okay, that means once again I will repeat what I said just now. That is, if a1 by a2 is not equal to b1 by b2, in that case, that graph of that pair will intersect at one point. In that case, that given pair has unique solution. Unique solution means one and only one value of x and y that given equation will satisfy. That is the meaning. Okay, that means this is the first case. That means you can see that these lines are intersecting at this point A, and in order to get the values of x and y. See children, what we are actually doing, we are finding the solution of a pair of linear equation through graphical method. Graphical method means plotting the graph. Okay, by getting the solution set, you will get the graph. Okay, and for this condition, if we have this condition a1 by a2 not equal to b1 by b2, so the graph will intersect at one point. What is our ultimate aim? We should get the value of x and y. That are the values of, that is solution of this equation. Okay, and in order to get its x and y, so you draw the perpendicular towards x-axis and see that the point at which that perpendicular meet on x-axis, that will give you the x value. And from here you can plot the perpendicular towards the y-axis, and that meeting point on y-axis will give you that y coordinate. And hence you can get the solution for x and y. And after getting the solution, okay, if your plotting is correct, both equations will satisfy with that x and y. That means you can make this LHS equal to 0 by substituting the value of x and y. You can make that equal to 0, and for the same value of x and y, the second equation is also satisfied. Understood? That is the meaning of pair of the for same value of x and y. You can see that both the equation will satisfy, and for that, what is the condition? That is a1 by a2 is not equal to b1 by b2. That is for that case, that given system, that given pair, the given simultaneous given equations will have intersecting lines. The graph will intersect at one point, okay, and it has unique solution. So the next case is parallel lines. Okay, when we can say that the graph of the given pair will be parallel lines. Okay, I already told without plotting the graph, by comparing the coefficients, okay, you can say that how its graph will look like. Okay, and for that you compare, after comparing, okay, see if you here this not equal to 4 intersecting lines. Okay, see some cases you can see that a1 by a2 equal to b1 by b2. In that case you have to find out this third case, that is c1, third ratio c1 by c2. If that third ratio is not equal to c1 by c2, the first two ratios are same and the last ratio is different. In that case, okay, without plotting this graph, you can easily say that their graph will be parallel lines. That means no solution. In that case, that given pair, for any value of x and y, both equation will not satisfy. That is no solution. So the graph will be parallel line and no solution. Okay, that is for intersecting lines a1 by a2 not equal to b1 by b2. In that case, you need not find out the third ratio. For parallel lines a1 by a2 equal to b1 by b2 is not equal to c1 by c2. And for this case, you can see that for no values of x and y, that given equations will not satisfy. Okay, that means their graph will be parallel lines. Okay, and the third one is coincident lines. When we get a coincident lines graph, and for that, if after comparing the given equations, okay, and what is the condition? a1 by a2 may be equal to b1 by b2. In that case, the third case also you have to find out the third ratio. If instead of not equal to, if all the three ratios are same, in that case, that given pair, their graph will coincide one over the other. They will overlap. Okay, that means it has, for coincident graph, okay, it has the infinitely many solution. For infinitely many values of x and y, that given pair will satisfy. That is its meaning. Okay, that means in this case, for coincident lines a1 by a2 equal to b1 by b2 is equal to c1 by c2. That means for infinitely many solution, here we have unique solution, no solution for parallel lines, and infinitely many solution for the coincident graph. That means if a1 by a2 equal to b1 by b2 is also equal to c1 by c2. So this is the main content of the graphical representation of pair of linear equations in two variables. For finding the values of x and y, that is the solution of the pair of linear equations in two variable, we have two methods. The first one is graphical method that we already have discussed, and second one is algebraic method. Okay, in algebraic method we have to solve for x and y without using the solution set and all. Okay, and for that children we have actually three methods, and first method is substitution method, elimination method and cross multiplication method. But cross multiplication method is deleted because of this COVID situation, so you have to revise only two methods, that is substitution method and elimination method. Okay, and for the substitution method, okay, what is the substitution method? In substitution method, suppose you have a linear pair of linear equation 3x plus 2y minus 4 equal to 0. Okay, and next is x minus y plus 2 equal to 0. This is a pair of linear equation in two variables. Okay, we have to find out its value by substitution method. Means you can express one variable with respect to other. For example, from this pair I am taking, you see that which of the variable having coefficient 1 if it is there. Okay, otherwise you have to express it in one variable one with respect to one term. Okay, and you can substitute that value in the second equation. But here in this equation, okay, in this pair, one of the variable, one of the equation, both variables having coefficient is 1. And in such cases, you have to select that equation first. Okay, and express that equation with respect to one of the variable. That what I meant is, you can keep from the second equation x alone by taking y and the constant to RHS. That is y minus 2 plus 2 become minus 2. And you can substitute this value in the first equation. Hence, you can reach into the solution set of solutions of x and y. And provided you can first see that what type of equation by comparing the ratios, coefficients a1 by a2 not equal to b1 by b2, that is a unique solution in that we already explained. Okay, so this is a substitution method. Substitute this value in first equation. If suppose this equation comes in the first, that is that the coefficient of x is, suppose for example here it is 2x and 3y, here it comes x, suppose this is the another pair. How this can be done, children? And for this pair, the first equation, the coefficient of x is 1. So what to do? You have to keep x alone in the first equation, and you can take the other terms into RHS, that is minus 2y plus 4, and you can substitute this value in the second equation. Okay, from which equation you are getting that value for substitution, you need not substitute this value again in the first. This value should be substituted in the remaining equation. Understood? Hence, you can easily get the value of x and y. That is substitution method. Okay. So, the second method is elimination method. Elimination method. What is elimination method? Okay, and for that I am giving one pair, that is 4x plus y minus 3 equal to 0. Okay, here I am giving you 3x plus 2y plus 7 equal to 0. We have to find out x and y by elimination method. See children, you can find out the solution any one of the method. If the method is specified there, that case only you have to use the different, that is specified method for finding the x and y. Okay, here how I am just explain what is elimination method now. Okay, you just make the coefficient of y the same, because see that any one of the coefficient is 1. So that we are making in elimination method the coefficient of the variable the same. Okay, so that you can easily eliminate. That means you can make this coefficient of y equal to the coefficient of y in the second equation, that is 2. How this can be done? You can multiply this coefficient of y by 2. that is 2. For that, children, you cannot multiply simply the coefficient, simply that term of y. You have to multiply throughout that first equation. Okay, that means by 2, since you need 2y should come in the first equation as the coefficient of y, and for that you have to multiply equation 1 with 2. That means 8, 4 2s are 8, and here the coefficient of y is 1, so 1 into 2 2, and here 3 into 2 is 6. That means by which number you are multiplying to make the coefficient of y the same, with that same number you have to multiply all the terms in that first equation. Okay, and hence you can see that now these y are the same. Okay, y term, the coefficients are the same. Then what we need, we have to eliminate. For that you have to subtract this equation 1 from equation 2. Okay, so 1 minus 2. So 1 minus 2, if you are doing 1 minus 2, you have to change the sign of the second equation, minus minus. Then you can add. So 8 minus 3x, 5x. Okay, this term get cancelled. 2x minus 2y get 2y minus 2y get cancelled, and here you will have minus 13 equal to 0. So 5x is equal to 13. X will be 13 by 5. This is the x value of x, and this value you can substitute for any one of this equation, given equation, so that you will get the value of the variable y. This is the elimination method. Okay, and another point, if you are getting any equation that is 3x plus 6y plus 9 equal to 0. This is a linear equation in two variable, not the pair. So whatever, even if it is pair or a single equation, okay, they see here 3, 6, 9. Between these three terms, you can see the common factor 3. In that case, you can divide this equation with all the terms with 3. Hence, this is also equal to x plus 2y plus 3, divide 9 by 3, 6 by 3 and 3 by 3. So the coefficient gets changed. Okay, hence you will get it's the simplest form of that equation. Okay, so this is elimination method. So usually we are finding the solution using elimination method. That would be easy for us. Okay, so children, using these two methods you can easily get the values of x and y. Okay, and the main application of this solution, see children, if we are getting a word problem, okay, in order to get the unknown values of two unknown values, you can easily form the equation by reading the context. Okay, you can easily form the equation, okay, pair of linear equations in two variables. Using two variables, you can express that context in pair of linear equation in two variables. And in order to get their values, okay, you solve using any one of this method. That is application. Okay, so if word problems comes in the examination, okay, you form the equation, pair of linear equation in two variable, and in order to get their values, you can apply any one of this method. Okay, and from using this, children, we are expecting a very important question, that is, suppose you are getting an equation x plus y plus 3 equal to 0. And a minus b into x plus a minus 1 into y plus 7 equal to 0. Okay, here also you can, sometimes it may be the value of k sometimes, okay, and find the value of k provided the given equation, the given pair has infinitely many solutions. In order to get the value of k, okay, what is the condition? You will be getting that condition will be there in the question. Okay, find the value of k provided the given pair has infinitely many solutions. So what to do? You have to write the condition for infinitely many solutions. That is a1 by a2 equal to b1 by b2 is equal to c1 by c2. And you can compare, that is a1 by 2, 1 by a minus b. Here the coefficient of x is a2 here, children, that is a minus b. Here that is coefficient b1 by b2, coefficient of y is 1, and here it is k. Okay, there you can see that k there, and is 3 by 7, and you can easily get that variable k. Understood? And sometimes the condition may change for unique solution. So a1 by a2 not equal to b1 by b2, and for parallel, that is no solution, that is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Okay, that is a very sure question, children, based on this comparison of the coefficients, and sometimes this question of this type can be definitely expected for the board examination. Okay, and also some cases you will be getting the contest, that is situational problems, okay, practical life problems, okay. So situational problems also make you equation and solve using any one of this method, that is substitution method or elimination method. Okay, that is the main application of this algebraic method of solving pair of linear equations in two variables. Okay, and another very important point, as I told, a pair of linear equation has three types of solutions. Okay, see, if it has unique solution, for unique solution, that system, that pair, system means that pair, okay, that pair is said to be consistent solution, consistent. The pair is said to be consistent when after comparing the ratios, that means that coefficients a1 by a2 is not equal to b1 by b2, that system, that pair is said to be consistent. Okay, and if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, that is for infinitely many solution. For unique solution, that system is said to be consistent, and here in this case it has infinitely many solution that given pair may satisfy. Okay, so that system is said to be also consistent. That means at least one solution. If a pair has at least one solution, that means infinitely many solution, that case also possible. Okay, it should have at least one solution, or for infinitely many solution. In both these cases, that is a1 by a2 is not equal to b1 by b2. In this case, as well as this infinitely many solutions, in both these cases, that given pair is said to be consistent. Okay, and what is the remaining one? That is a1 by a2 equal to b1 by b2 is not equal to c1 by c2. In that case, that system, that pair is said to be inconsistent pair. Okay, that means after you comparing, if you have that relation, you can say that that type of pair of linear equation is inconsistent pair. Okay, so consistent and inconsistent is clear, children. And we have one more cases, that is a dependent solution. When a pair is said to be dependent, only when it has infinitely many solutions. Okay, sometimes you are getting a linear equation in two variable, that is x plus 2y minus 3 equal to 0. Sometimes the question paper you can see that you should write an equation or select that equation which is matched with that dependent solution of this given. That means you have to apply this case, that is a1 by a2 is equal to b1 by b2 equal to c1 by c2. Okay, in order to get the same ratio, here the ratio is 1. If I am taking 2x, so the a1 by a2 equal to 1 by 2. Okay, here the a1 is a coefficient of x in the first equation, that is 1. So 1 by 2. So here what do you have to write? You have to make this b1 by b2 also same as 1 by 2. Okay, and for that, here already is 2 plus 2. Okay, I have to divide this with 4y. So what happens? 2 by 4. 2 by 4 is also 1 by 2, right? And c1 by c2 constant also 1 by 2. So you have to divide this minus 3 with minus 6. Don't take plus 6. Okay, if you are writing plus 6, what will happen? Minus 3 plus 6 is minus 1 by 2. But we need 1 by 2. So minus, you have to take minus 6. Okay, hence you will get minus 3 by minus 6 is equal to 1 by 2. That is equal to 0. That means in this case, okay, this is the required equation. And you can start with 3, doesn't matter. So you saw that you have to multiply with 3. Here also 3. If you have the coefficient of x starting with 2, that means you have to multiply other terms also with 2. Then only this condition will satisfy. Okay, so for dependent solution, we have to follow this infinitely many solution. That condition is okay for this dependent solution. Okay, but for consistent system, if you are talking about consistent system, there can be of two type. For unique solution, at least one solution, and for infinitely many solution, that given system is said to be consistent. Okay, for parallel and condition, that is no solution, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, that is inconsistent system. Understood? So the next topic is equations reducible to pair of linear equations in two variable. Okay, and that means some cases that given pair need not be satisfied the general form of pair of linear equations in two variable. What is the general form, children? That is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This is the standard form of pair of linear equations in two variable. Okay, but instead of that type, you may given in this form, the pair may be of this form, that is 2 by x plus 1 by y minus 1 by 2 equal to 0. Or here 2 equal to 0. Here 3 by x plus 2 by y minus 7 equal to 0. Okay, see, in this case, can we say that this is okay with that standard form? We can't, children. Why? Because in the original, that is the standard form of pair of linear equation, the variable is in the numerator, x, here y. Okay, here also x and y. But in this given equation, you see that the variable x is in the denominator. Okay, in such cases, what to do? You have to give substitute. You have to reduce equation reducible to pair of. You have to reduce this into pair of linear equations in two variable. And for that, children, here 2 by x is, what is 2 by x? This is equal to 2 into 1 by x. Okay, and what is 1 by y? If it is 3 into 3 by y, suppose. Here it is, what is it? 5 by y. Okay, what is 5 by y? 5 by y is 5 into 1 by y. Even if 1 by y doesn't matter, children. Here we can take 2 by y is 2 into 1 by y. I just want to explain what is 5 by y means. Okay, see, in such cases, we need this in the numerator, the variable in the numerator. Okay, 1 by y also in the numerator. And for that we are giving substitution, or put 1 by x is equal to p or u, any other variable other than x and y. And also 1 by y is equal to q. So that this equation becomes, how it can be, that is 2 into 1 by x, so 2 into p plus 5 into q, that is 5 into 1 by y. 1 by y we are giving substitution as q. Okay, minus 2 equal to 0. Here also second equation also the same application, that is 3 into 1 by x, that is 3p plus 2 into 1 by y, that is 2q minus 7 equal to 0. See, children, here we have a pair of linear equations in the variable p and q, that doesn't matter. Then you solve this either using elimination method or substitution method. Okay, you can make if you are using elimination method, make this equation the coefficient of any one of the variables same. Here how you can make this coefficient of p or q, you can be, that doesn't matter. That is, you can multiply this equation 1 with 3. So 2 into 3, 6p and 15 and minus 6 equal to 0. So what to do in order to make the coefficient of p of the second equation 6? You have to multiply the cross the multiply. Okay, that means you multiply this with 3 and the second equation with 2. So 6p and second also you will get 6p. You don't bother about the q and the constant. Our aim is to make the coefficient of one of the variable the same, so that p can get eliminated. You will be getting the value of q. And that q, the value of that variable, can be resubstituted in any one of this. Okay, suppose you are getting the value of q as 2. Okay, and then you substitute that q, the 2 as this value of q as 2 in this first equation. So what will be 2p plus 5 into 2, that is, we got the q, suppose 2, so 10 minus 2 equal to 0, that is 2p is equal to minus 8, so p is equal to minus 4. That means then you will have this equation become linear equation in one variable, because we got the value of q already. Okay, hence you will get the value of the second variable p, and after getting this p and q, you substitute here. Okay, so that you will be getting x, and our aim is to get the variable included in this involved in the first the given original pair. Okay, and for that we are reducing that into this form, its original form, hence get p and q, and you resubstitute here. That is here we have 1 by x is equal to minus 4. Okay, and we need x, that is x can be cross multiplied, so you will have minus 1 by 4 equal to x. X will come to numerator and y will come, that is minus 4 come to, that means the value of x is minus 1 by 4. The same way 1 by y equal to, that is q we have got 2, so you can take 2 here, and in order to get y, y will cross multiply, so 1 by 2 is equal to y. This is the this method is what we call equations reducible form. Pair of linear equations should be reduced. The given equation should be reduced in the form of pair of linear equations in two variable. And for that is, you see that where is that the variable comes. Okay, if it comes in the denominator, you have to follow this method. Understood? And the final topic, that the last topic of this lesson is the concept of upstream and downstream. The speed is given. See children, that is the very important point is, if a boat is rowing towards upwards, that is upward direction, okay, that means that a boat has automatically, it has original speed. Okay, let it be speed of the boat is x. Okay, if it is moving in the still downstream, okay, now the last point, that is upstream and downstream. Okay, suppose a boat is moving, that is towards the upward direction and downward. Now the last topic is regarding the upstream and downstream, okay, speed of the boat. Regarding that we can expect one question. See children, in that case, that boat can move, when we are moving in the sea, that is in the ship, you can see that up and down we can experience, okay. And if the boat is moving towards the downwards, that is downward stream, that boat has already, it has got speed, okay, that means let it be x. And that current, speed of the current means water, that is, water has its natural speed, so you can take the speed of the water is y. So if the boat is moving towards this downstream, okay, that will complement to that the speed of the water will complement to the speed of the boat. That means you have to add the speed of the current with the speed of the boat. That means in that case the speed will be x plus y. That x denote the speed of the boat and y denote the speed of the current, speed of the water. Okay, that means that here the speed becomes the speed of the boat in the downstream will be x plus y. And you can apply that is speed equal to distance by time. So accordingly you can relate this, you can form the equation. Okay, and second case is sometimes we can experience that boat is moving upward direction. In that case, that original speed of the current, that is water, is opposed by, that is you have to subtract that speed of the water, the speed of the current, from the speed of the boat, because the boat is moving upward and the water is coming down, or always the water has a tendency to move downwards. Okay, so there is we can experience an opposing force. Okay, so that you have to subtract the speed of the water from the speed of the boat. That means in the upward direction, upward stream, okay, upward stream, the speed will be x minus y. Okay. So children, these are the very important concept comes in this pair of linear equations in two variables. I hope you have now got a very clear idea about of this lesson. Okay, so do practice, and with the problems which we already given and from the papers which we have solved. Okay, so thank you children, thank you for watching and supporting my channel. Thank you all.